So I'm going to start the Chapter 10 RStudio assignment by working on Task 1. So for Task 1, we are looking at 3 different groups of teaching styles and looking at what effect that has on students' exam scores. The first thing I'm going to do for Task 1 is get the descriptive statistics for each of the groups of teaching style, and you can see that I'm going to use the by function for that, which runs the descriptive statistics function but separates out the results for exam scores based on the teaching group. So I'm going to go ahead and run that. You can see that it separated out group 1, 2, and 3, and I get all the descriptive statistics, including the mean and standard error that I'm going to need for the results section write-up. The next thing that I have to do before I can run the ANOVA is set the categorical variable here that we have, which is the group variable, to be a factor. So I'm going to use the factor function to do that. And you can see that I'm setting that there are 3 levels of the group variable with the labels 1, 2, and 3 for the 3 different groups of teaching style. And I'm just going to push that into the pre-existing variable for group and just set that same variable as a factor. So I'm going to go ahead and run that. And then you'll be able to see over here in the data set that it's actually factored it with 3 levels now. Next thing I'm going to do is conduct a Levene's test to make sure that the assumption of homogeneity of variance is met before running the ANOVA. So you can see I'm doing the Levene test function here, once again with the outcome variable being exam, the predicting variable being group. I'm going to run that, and you can see here that the p-value is not significant, therefore the assumption is met, and we can assume that there's a homogeneity of variance, which means we can run a regular one-way ANOVA. So that is the next thing that we're going to do, is run the ANOVA. You can see here that I'm using the AOV function to do that, once again with exam being the outcome variable, group being the predictor variable. And it's going to be coming from the data set labeled teach. So I'm going to go ahead and create this model and name it teach model. And then I'm going to get the summary of this, which will show the results of the ANOVA. And you can see from the results of the ANOVA that there is a significant difference between the groups happening here, with a p-value of 3.15 times 10 to the negative 6. So there definitely is a significant effect here, or definitely a significant difference between the groups. Next, I'm going to look at the effect size. So I'm going to use the summary.lm function to get the r-squared for the model. You can see in the output here, it gives an r-squared of 0.6088. So then to get the effect size, I'm going to take the square root of that, which gives an r of 0.780. So there is a large effect in addition to the difference between the 3 teaching styles being significant. There's also that effect is quite large. So from this we can conclude that teaching style does have both a significant and large effect on the students' exam scores. So now moving on to task number 2, we're looking at 4 different groups of superhero costumes, and we're looking to see if there is a difference in the severity of injury sustained while wearing a costume if there's a difference dependent upon the type of costume. So once again, I'm going to start by using the by function to get the descriptive statistics. I'm going to run that. You can see that we have the 4 groups here, each with their descriptive statistics, including the mean and standard error, that I'll use for the results section. Next, once again, I'm going to set the categorical variable to be a factor, and here that variable is hero. So you can see I've created the labels for each of the 4 different types of superheroes and set the levels to be 1 through 4. So I'm going to set that variable to be a factor, which now if you look over here, you can see that it's been factored with 4 levels with those specific labels. Next, I'm going to create a graph with the error bars using the ggplot function to create the object that will specify the graph. This is going to come from the hero data set, and once again we're going to be looking at hero and injury. So then I'm going to be doing a line graph. So the geom will be point, and it'll be graphing the mean of each group. So that's set here in that function, and then here you can see I've set the function for the error bars based on the confidence interval, as well as the labels for the graph right here. You can see that these 2 different summaries here, one of them gives you the point, which represents the different means. The other gives you the line piece of the line graph that connects the different means together. I'm going to run that, and then you can see here on the right what that looks like. So looking at this graph, you can see that the Superman, the mean injury severity of those wearing the Superman costume does seem to be higher than the Hulk group as well as the Teenage Mutant Ninja Turtle group. This does not appear to be significantly different because the error bars overlap here. This one is very close as well, but I would predict that both of these groups are probably going to be significantly different and significantly less injury severity than the Superman group that you see here. There likely will not be a significant difference between Spider-Man and these 2, just because the error bars overlap for those comparisons as well. So with that in mind, now we're going to run the Levene's test to once again test the assumption of homogeneity of variance. So as before, I'm going to use the Levene test function. And we can see from the Levene's test output down here that the Levene's test is not significant, which means the assumption of homogeneity of variance is met, which means we can go ahead and run our one-way ANOVA, which we're going to do next, once again with the AOV function, with injury being the outcome variable and hero being the predictor variable. So I'm going to go ahead and run that, and then run the summary to get the results of that. And you can see that the one-way ANOVA is does show a significant difference between the groups in the scores of injury severity. Now we're also going to do the effect size for this one as well, which using the summary.lm model, you can see that the r squared is 0.4897, and I'm going to take the square root of that, which gives you an r of basically 0.700 when it's rounded up. So this indicates not only is there a significant difference between the groups, but that this the effect of the different costumes is a large effect on the injury severity scores. So the last thing I'm going to do is I'm going to do a multiple comparisons post hoc test. I'm going to do a Bonferroni test, which you can see here. I'm going to use the pairwise t-test function for this. I'm going to be once again looking at injury scores compared to injury scores with a grouping variable of hero. Paired is going to equal false because each group is independent. It's not the same people being assigned to each group. It's actually separate groups, so that's going to be false. And then I'm going to be using the Bonferroni test, so that'll be the adjustment method for P. So I'm going to go ahead and run this, and what this is going to do is going to show the comparisons of all of the different groups. So Superman to Spider-Man, Hulk to Spider-Man, Hulk to Superman, Teenage Mutant Ninja Turtle to Spider-Man, Superman, and Hulk. You can see that the only ones that showed a significant difference were Superman compared to Hulk and Superman compared to the Teenage Mutant Ninja Turtles, which is actually what we predicted. If you look back over at the graph, that's actually what we predicted from looking at the graph, because those are the two comparisons that did not have the overlapping error bars. So that is the end of this Chapter 10 RStudio assignment, since we did not have to complete task number 3.